Hi, welcome back again. In this video, we will look at the tangent line from a different perspective. Let us, for example, look at the following graph of the sinus function on the screen. What happens if we zoom at the vicinity of a fixed point? Let's say the point 0, 1. For example, if you zoom a little bit, then the shape doesn't change much. Zoom in again and the graph starts to resemble a line. Zoom in again and this becomes even more clear. And if x is very close to 0, then the graph is almost a straight line. Which line? The tangent line. In the previous video, you have seen how to find the formula of the tangent line to the graph of a function in a point on the graph. In this video, we will look at the linearization, which is an alternative way of looking at the tangent line. If we say y is f of x is a function, then we have seen that the tangent line to the graph of f of x at the point with coordinates a, fa is given by the formula on the screen. The linearization L of x of this function fx at x is a is the linear function whose graph is the tangent line. The formula of L of x is given by f of a plus f prime of a times x minus a. By the way, it does not make sense to talk about the linearization of a function, but it makes sense to talk about the linearization of a function in a point. The idea of a linearization of a function in a point is that we are looking to replace a function locally, meaning close to a point, by a line. In other words, a linear function. Look, it doesn't make sense to replace the sinus function on the screen by a linear function. You miss literally everything what is essential to the sinus by representing it by a linear function. Look at this green line. It is a poor approximation of the blue graph. It doesn't follow the twists and turns of the graph of the function. But if you zoom again at the vicinity of the point 0, 1, then they are essentially indistinguishable. For example, if we zoom once, then the approximation is rather poor. Zoom in again and it becomes already better. Zoom in again and it becomes very decent. And if x is very close to 0, then the approximation becomes pretty good. So close to the point with coordinates 0, 1, the green line is a very good approximation of the blue curve. This is the idea of linearization, that we can approximate a function by a linear function close to a given point. Which linear function? The one whose graph is the tangent line. To recap it, the tangent line to the graph y is f of x of the function f at x is given by the expression on the screen. To obtain the formula for the linearization, just replace y by L of x. So the values of f and L in A are equal. Also, the slope of L at A should be equal to the slope of f at the point A, so that derivatives should be the same at A. So L of x is an approximation of the function f of x in the vicinity of x is A. You might ask, how big can this vicinity be? This depends on the function f of x. Some function can be better approximated than other functions. We will discuss this in a later video. Let us become a bit more explicit. Here you see a square root function. F of x is the square root of x plus 3. What is its linearization? The value f of 1 is the square root of 1 plus 3. That is 2. Thus, the tangent line passes through the point 1, 2. The formula for the linearization is given by L of x is equal to f of 1 plus f prime of 1 times x minus 1. Now, the derivative of f of x is given by 1 over 2 times the square root of x plus 3. Evaluating this in the point x is 1 gives f prime 1 is given by 1 over 4. Thus the formula for the linearization is given by 2 plus 1 over 4 times x minus 1, which can be simplified to 1 over 4 times x plus 7 over 4. Now, what can we do with this? Suppose we want to calculate the square root of 4.05. The easy way is to use a calculator. What would you do if you are not allowed to use one? Linearization, of course. Take the function just considered. F of x is the square root of 3 plus x. The idea is that close to the point x is 1, the function f of x can be approximated by L of x. The square root of 4.05 is the square root of 1.05 plus 3. In other words, it equals f of 1.05. But for values close to 1, this is approximately equal to L of 1.05. Filling in x is 1.05 in the formula for L of x yields 2.0125. A calculator gives easily the first 10 decimals. In the next video we will see how calculators achieve this.